In this video, I'm going to show you how to create this dynamic animated water droplet shader in the Unreal Material Graph. You're going to need a simple noise texture for this. You can download the one I used as well as the final Unreal project on my Gumroad, or feel free to use your own noise texture. So we're going to start off by creating a new material, and we're just going to call this mt_dynamic drops. Let's immediately right click, create a material instance, and then I'm going to immediately drop it onto my sphere. Let's open up the main material now, and we're going to start off with the static drops. So dragging my noise texture into the material graph now. So let's drag off this, and we're going to look for a smooth step, and we can reconnect this output to the value instead. Let's right click on the min and max, and we're going to promote these to parameters. Set the max to a default value of 1. And just for preview's sake, we're going to plug this into the base color for now. We also want to set up some tiling so we can control the size of the drips on the ball. So let's just create a texture coordinate and a multiply node. And we can plug the texture coordinate into the A slot of the multiply, create a scalar parameter, convert it to parameter, and we can just call this tiling. A default value of 1. And plug this into the B of the multiply and the multiply into the UVs. Okay, so now we have the setup for the static drips. Let's save this material. Now in our scene, we're going to open up the material instance that we created and placed on our sphere, and we can just take on the min and max. If we bring up the minimum now, you can see we begin to isolate areas. You can see there is some color banding going on here, so I am going to go back into my material graph, and we don't want the RGB, I just want to grab one of the channels and resave that. Okay, now the value is grayscale. We can continue to play with these. Values I like, which I found was 0.95 and 0.85. Let's also bring up the tiling somewhat, so we have more drips, like so. The smooth step function is going to isolate any of the grayscale values between these two values that we are setting in our instance material. So you can see here we've isolated the values of this texture between 0.85 and 0.95. And we get this sort of droplet mask. To make it a little neater, I'm going to right click in my material node graph and add a named reroute declaration. And we're just going to call this static drip mask. If we preview this, this will allow us to call this result anywhere else in our graph without having all these spaghetti lines everywhere. So an example of this, if we now go here and type static drip mask, we can plug that straight into the base color, and then we don't have to have this line anywhere. Let's grab everything here, right click and create comment from selection, and we can just call this one static drops. And I'm going to default these values to the values I set in my material instance, because I know that I like these values. So 0.95 for max and 0.85 for min. Let's now duplicate this, grab everything and Control C and Control V. We're now going to work on the animated dynamic drops. Let's recall this dynamic drops. And we don't want these parameters to share across each drop type. So I'm going to start renaming this. So we can call this static tiling. And these two we can call static min and static max. We can also grab all of them and put them in a group, and we'll call this group static drops. Let's do the same for the dynamic drops now. Okay, cool. So now we have this. Let's see if we can just combine these two drop types. First, let's add a different named reroute node for the dynamic drops, and we'll just call this dynamic drip mask. And we can plug this in here and delete this one. Just to ensure that we can control both drip types separately, let's use an add node and place this up here. We'll put the static drip mask into A, and let's find the dynamic drip mask, and let's just put this into B and hook that up into the base color. Let's save our material. Okay, now in our instance, we can see the dynamic scalar parameters here, and if we change the tiling, we can see they are indeed separately controlled. Let's add these to their own group now. Select all of these, and we are going to call this dynamic drops. Okay, cool. So now we have the dynamic and static drops in separate layers. We need to now stretch, distort, and animate the dynamic drops. So let's start by doing that. First things first, we are going to stretch them. So let's grab this one and copy and paste it. And we can name the first one dynamic X tiling and the second one dynamic Y tiling. Let's right click and search for an append vector. Plug X into A and Y into B, and then plug this into the multiply of the texture coordinate. Let's save this again and have a look now at our material instance. So you can see now we have a dynamic X tiling and a dynamic Y tiling. We've set them both to 1. So we want them to stretch longer in the up axis. So that I think would be Y. So if we increase the tiling on Y, it is not. We need to increase the tiling in our X parameter, funnily enough. So let's do that. And now you can see we are starting to get the shape of running drips. So let's go back and we need to now animate these dynamic drips. Let's right click and search for panner, add a panning node, and we can grab all our tiling nodes, replace them here, and put them into the coordinate of the panner, and the output of the panner into the UVs of the dynamic drop noise texture. Okay, cool. So now we want to be able to control the speed of the drops, how fast they're animating. So we can actually grab all this, and we want to do dynamic X speed and dynamics Y speed. Actually, we won't need to animate it in the X-axis. So what we can do, convert this to a constant and set it to a value of 0. And now we only have control on the Y speed. Let's plug this into the speed of the panner node, save, and take a look at our instance again. Okay, so now you can see our drips are animated, but they are going way too fast and also in the wrong direction. So here in our material instance, let's take dynamic Y speed, and we want to have this at a negative value. So let's try something like negative 0.2. And you can see it's starting to look a little bit better now. These look like they are sliding down the surface a little too perfectly. Usually you'll see raindrops deviating in their path when dripping down a window pane or something. So let's add that next. We're going to go back to our material graph, and we can grab this texture sample with our noise and just control copy it. And then we want to use an add node here where our texture coordinates are coming in from the panner. Put the result of the panner into A, and then the result of the red channel from our noise into B. And if we plug these into our UVs, you can now see the drops are doing something kind of crazy. So we need to fix that. I want to add controls for tiling of our distortion texture. So let's add a texture coordinate here and use a multiply and a scalar parameter. And we'll just call this distortion tiling. Set this to a default value of 1. And add that into the B, and then the output of the multiply into the UVs. And I also want to control the power of the distortion, how much it will affect the drips overall. So just add another multiply here and plug that into A, and then another parameter, and we'll call this one distortion power. If you don't know how I'm quickly getting multiply and scalar parameter nodes, if you hold down 1 on your keyboard and left click, you get scalar nodes. And if you hold down M and click, you get multiply. So let's put the distortion power into multiply of B. I'm gonna leave that at a default of 0 for now, and plug the result of the multiply into the B of the add. We can create a comment from this, and let's just call this distortion. And we can also add a group with these scalar parameters. We're gonna call this group distortion. Let's save the material and head back to the instance. So you can see now we are back to no distortion. So if we open up our distortion now and up the power of the distortion, you can see things start to get a bit wobbly. If we increase the tiling, we can get something a bit more how we would like it. So let's try 1 and 0.02 maybe. Bring down the scaling to 0.5 or maybe even 2. Okay, cool. I'm going to reduce the speed a bit more. It still feels a bit too fast for me. And there we go. You can now, if you want, play with the amount of dynamic drips, something like this maybe, and also just the static drips, whatever you want. Okay, cool. So we have our masks now. We need to get the roughness for the drops, and we need to generate a normal from the white mask we get. So let's do that next. I'm just going to add this to the dynamic drops comment by dragging out the box a bit more. Okay, cool. So now we have dynamic drops here and we have static drops here. Let's first create a normal map. So I'm going to use a node called perturb normal. We have to first prepare the perturb normal, and then we want to use a perturb normal HQ, and we can plug the top 3 into the other top 3. And the value is the black and white masks that we will create. So if we just grab this and duplicate it, because we want both dynamic and static drips, we have them here. If I right click on the add node and start previewing, you can see we get the black and white values. So let's add this into our perturb normal and stop previewing this add node. And let's preview our perturb normal high quality. Okay, so now you can see we are getting some weird red result. This is the normals, but it is in world space. We need to transfer this to tangent space normals from world space, so we will get correct shading and lighting on our model. So let's do that now. It's pretty easy. We just use a transform vector and then plug the world space normal into the input slot, and we want the source to be world space and the destination to be tangent space. And there we go. We now, if we click this, you should see something resembling a more normal map. Now we want to be able to control the intensity of this effect. So let's just drag off here, create a component mask. This is masking the red and green channels, and duplicate this, and we want to just mask the blue channel. Then dragging off the red and green mask, use a multiply and a scalar parameter. We're going to call this one drip normal strength and set this to a default value of 1. Let's try that. And then to append this all back together, use an append vector and the top one into A and the blue mask into B. And then we can create let's actually add a reroute. And named a reroute declaration, and let's just call this normals, or in fact let's call this drip normals. And let's bring this off to its own area, and we can create a comment, and let's just call this normals. And I'm going to stop previewing the transform vector. And then over here we can use normals wherever drip normals, and then plug that into our normal slot of our main material. And now if we save this and go back to the scene, we should be able to see the result of a normal map. Okay, so now you can see we are getting a normal map result. Unfortunately, it is kind of stepped. I haven't figured out a way to reduce this yet, but we can control the intensity of the normal power. So we can increase it, or it's gone crazy, or decrease it. The result is kind of low resolution up close, but if you zoom out slightly, it's not noticeable. So now we have the mask and a normal result from that mask. Next, we want to control the roughness intensity of the drips separately from the main material. So let's do that. So I'm going to use a linear interpolate using this mask we already have with the static and dynamic drips. Let's put that into the alpha. That means any value that is white will take the B value, and anything that is black in our alpha will take the A value. So let's create 2 scalar parameters. We'll call this one drips roughness, and we can call the other one base roughness. Let's set the base roughness to something like 0.5. Drip roughness, we can keep it 0, and let's plug that in, and then plug that into our roughness slot. Let's add these to a material group. We can also add the normal map power to the material. Save that and take a look. Okay, so now we can see we can adjust the roughness of the base material underneath the drips, and we can also adjust the roughness of the drips themselves. It's a little hard to see with the black and white mask applied to the base color right now. So let's do that next. We want to add a vector 3 and change this to a parameter as well. And let's just call this color. and plug that into our base color. Save material and let's have a look again. Okay, we can see it a bit clearer now. Drips roughness we can bring way down. Let's bring down the roughness strength of the normals. It's a little too high at the moment. And let's also change the color of the material itself, maybe like a dark blue. Okay, and then you have it. You have now a dynamic drip material, which you can use with other materials. So if you want to just plug in normal textures, you would just plug them into here. If you had, say, a roughness map of your own, which you have textured in Substance Painter or something like that for an asset, you can just use an add node and add the roughness from here. Then plug your texture map into A, and then this into the roughness slot. Same thing for the normals. We have the drip normals here. If you want to combine normals from the drips and a texture map you created, use a blend angle corrected normals is the one I'm looking for. So you would add your normal texture into the base normal, and then you can slot the drip normals into additional normal, and then this into the result. You need a texture in here for it to work. And then you have drips over your textured asset. You can grab the project file with the finished shader on my Gumroad, or if you want to learn more about creating art for games, check out my other tutorials, like my complete stylized game asset course, where we will create a game-ready asset from start to finish, including lighting and portfolio renders. Or if you want something a little smaller, check out my free tutorials on my channel, including stylized texturing and sculpting for games. Thanks for watching the video, and I will see you in the next one.